All right, welcome everyone. I'm super excited. This is getting official now. We have Team Teardown t-shirts. Yes, shout out to our marketing team for making that happen. Joined here by Chris and Molly, select members of Team Teardown. We're going to wait just a few minutes for everyone else to file in. This is our laptop edition. Super excited. This is the first laptop we've actually torn down. And while we're waiting for everyone, we're going to talk about our experience with laptops. So for those of you joining, we want to hear about the first laptop that you owned. So please post that down in the chat on the bottom right. And please, you have to change that little blue dialog to send it to everyone. Zoom has still not, heard my feature request to make that a default. So change it, send it to everyone. Tell us about your first laptop and introduce yourself. Let's start with our team here. Maybe Chris.
Yeah, so my first laptop actually was when I started my first job at Amazon, and I was given, struggled to call it a laptop. It was more like a lap crusher. It was like a 17-inch desktop replacement Dell that was about 9 pounds, and I lugged that thing to China probably like 20 times. I think I had probably needed some chiropractic adjustment afterwards. So that was my first laptop. What about you, Molly?
Yeah, mine was also chunky and heavy. I think when I was going to college, I got a Lenovo ThinkPad. Definitely took up a lot of space and a lot of weight in my backpack for all those years. But it was a solid machine. It was good. What about you, Tobias?
Funny enough, you should say that. I've got a little surprise for Chris and Molly here. Also, a Lenovo ThinkPad. And just before this, actually, I went up into my attic and dug through some boxes, and I was able to find the Lenovo the T430, pretty chunky here.
There you go.
I forgot how modular it was. The battery pops out, replaceable battery. I think I had 2 batteries. And there's also a cover. I remember I installed some upgraded RAM at one point. And then I think my favorite part here is you can actually swap out some of the drives. The whole CD drive actually just comes out, which is pretty impressive.
Now when you take it to work, you don't have to take the CD drive, right?
Yes. We were actually looking for a CD drive at work the other day and could not find one. So another very controversial opinion here is on the mouse. The different types of mice. Do you guys remember the little nubbin in the middle? Would love to hear opinions from the audience on if they love or hate that nubbin mouse. All right. I want to make sure. I did see one question that the chat is disabled, so we'll make sure that that's working as we dive into it, because we do want to hear from you guys which laptops you have. But let's go ahead and dive into it. So welcome everyone to Change Notice on Snap. This is our monthly teardown series. I think we're going on our 12th teardown now, which is super exciting. We discuss all things electronic, supply chain, manufacturing. I see a lot of our regulars coming back, so welcome back, as well as a lot of new names. So please go ahead and introduce yourself in the chat. Our goal here is to build a community, share knowledge, and really continuous improvement. So a couple reminders. One, if you do need to leave, please fill out the survey. That's how we decide what we're going to do differently next time, what we're going to tear down. And as with all of our teardowns, we don't have any insider knowledge on this laptop that we're going to tear down. But even better, we have a team of experts, Chris and Molly here, as well as you guys in the audience. Please let us know if you have worked on laptops in the past, because we look forward to your questions. So I'll hand it over to Molly, maybe for some introductions.
Sure. Hey, I'm Molly. I'm a solutions architect with Instrumental, and I've been here about a year and a half. But before that, I was actually working on laptops. I worked at Google working on Google branded Chromebooks, specifically the Pixelbook Go. So I do have a little bit of expert knowledge here on laptops specifically. And with that, I will pass over to Chris.
Yeah, my name is Chris. I used to work at Amazon on a bunch of Kindle products. I worked there for about 7 years. And more recently now, I am at a self-driving tractor, autonomous tractor startup called Autonomy. So it's a slightly different space, but still using those mechanical principles. Tobias, why don't you give us a little intro?
All right. Also, mechanical engineering background, worked at Apple for about 6 years. Did not work on any laptops, worked on phones and watches, technologies, health technologies, and touchscreens. And now I'm at Instrumental leading our business development team. And with that, just an overview of our agenda, we're going to dive into the live teardown. We're going to talk about a lot of the design decisions made. If you guys have questions as we go along, we want to hear which modules you want us to dive into. I think we're having some technical issues with the chat, but luckily there's another option. So there's the Q&A button down at the bottom. So you can go ahead and use that instead of the chat here. So with that, let's go ahead and dive into the teardown with Chris.
Yeah, let me share my screen here. We got our fancy new instrumental background, but this is the laptop. So first of all, why the Surface laptop? We've gotten a lot of requests for laptops in the in the survey that comes back, and so we thought, why not go ahead and do one? And we picked the Surface laptop just because we think they've kind of changed a lot over the past maybe like 5 years or so. I think they first released the Surface laptop, and we kind of heard about the iFixit and challenging repairability score of a 0 with that Alcantara fabric on the top. This one is a lot sleeker. It's all aluminum. It's got the same pretty big generous trackpad, the chiclet style keyboard, a couple of ports here. We got the USB-A, USB-C, and microphone headphone jack. And then on this side, what looks like a SD card slot, but it's actually their proprietary Surface Connect port. Yeah, so this one, and then I think this one also comes with a couple of, it's hard to see, but some cameras and things in there, so you can do the easy Windows Hello sign on. So yeah, just taking a look around the rest of the laptop, it's a pretty clean surface, just a bunch of aluminum surfaces. Let's wait for it to come back. And unlike a couple of other laptops, like the Apple laptops and some of the ones that I think Molly may have worked on, I only see 4 screws on the back, which is a little bit unique. So I'm going to go ahead and take those off.
Yeah, the ones I worked on, for reference, I think had 10 screws around the perimeter. So yeah, 4 is pretty incredible.
I think I'm using a T5 screwdriver here.
Yeah, those screws also look really small.
They are. So there you go. Pretty small screws. And so I think, unlike other laptops where you can kind of pop off a back cover, I think I might have to open this from the front. So let's see if I can sneak in here. There's a seam around the outside.
Alex, yeah, so Alex had a comment here. First off, also Lenovo T43 gang, but also on the back panel, I think the back panel must be pretty stiff to have only 4 screws. So maybe we can look at that once we get that popped open.
Yeah, let me get a second here. This was easier before.
We got some Asus first laptop as well.
Yeah. All right. Well, this is actually, the whole thing is popping off right here, which is great. Looks like it's held on with a bunch of magnets. And just pop this off. All right. There you go. So you got 2 big sections here. This looks like it's more of a bucket style, which is a little bit different. Usually the bucket goes the other way and it kind of encases the keyboard. This one, it's like a kind of reverse construction where the bucket is on the bottom and you got the trackpad and keyboard up top here. Let's see, is there anything else we want to see here? Otherwise, maybe we can zoom in on instrumental and get going. There's a lot of screws here, so I'm going to probably have to spend some time to take this apart. Why don't I switch over to Molly?
Why do you guys think, yeah, that's really interesting that that's the keyboard that pops off instead of the back cover. I think Alex was mentioning the stiff back cover. It's actually completely reversed. I'd like to hear from the audience, why do you think that this design, they switched it over instead of having the back cover removed and doing this bucket assembly? Any thoughts? Molly, what do you think?
Well, yeah, I will just share that it does now make more sense that they only need the 4 screws. Like Alex mentioned, so that the bucket will make it much stiffer back cover versus like a typical, more like basically sheet metal, really thin sheet metal sheet just being that back cover. Yeah, I guess, I mean, I'm thinking about like their previous Alcantara designs and if that might have informed some of this. What other thoughts do you guys have?
Yeah, I mean, one thought I had was maybe when they started to do their hardware, they kind of started from the Surface tablets, and maybe this is almost like a slightly reminiscent of a tablet construction where everything goes in the base. They do have the various styles where they're propped up, or it has like the Surface Book kind of thing, and so maybe they just said this is a similar architecture. It's easier, we understand it. I don't know. That was just some random thought.
Yeah, I mean, I think one other thing too, if you think about it, the keyboard and the trackpad would be pretty commonly replaced items or repaired items.
Oh.
And how easy would it be to swap out that top cover based on what you just saw? So that could have been one of the motivating factors too.
Absolutely.
Plus one for iFixit and repairability. I love it.
Cool.
We had one question from Alex on, after you open that up, that along the bottom there, are those all batteries? Maybe we can take a look at that bottom picture there. Just
Yeah. Yes is the answer. I think we see like a black bracket that holds this battery pack together. Looks like we have 6 different cells here. But yes, this whole area here is battery.
Looks like they're using six different cells, so they kind of look almost like, I don't know, cell phone batteries or something that are kind of in an interesting arrangement.
Yeah, that was my first thought too, is coming from cell phone design in the past. It looks like almost 6 iPhone batteries just stacked side by side.
I will guess that that's probably not the case, but I think there's some reason to still put them in individual cells like this for efficiency. And yeah, let's jump into looking at this area. So a couple things on this keyboard kind of enclosure subassembly that I noticed here were, one, we see this kind of mesh here. And I'm curious, it almost looks like some kind of audio mesh. So kind of maybe to the audience or to you guys, Tobias and Chris, what do we think this might be?
It's a good question. So it looks like a mesh that's over the black tape on the back and then has an opening. And are we seeing the keys on the other side, the keyboard there?
I think that might be kind of the perimeter of keys that we see, those 3 openings. Yeah.
That's really interesting. Can we tell what's on the bucket side that might be pressed up against that mesh?
Yeah, let's take a look. That looks like a speaker. Which is pretty interesting. I mean, if you think about like MacBook or a lot of other laptops, you would see like a grill on the 2 sides of the keyboard. And we didn't see that on the top of this laptop. So yeah, it almost seems like sound might be traveling through the keyboard, which is kind of wild.
That's interesting. Oh yeah, there are no other ports for sound to come out, so it must come through the front. I'm impressed that they're able to get that without like vibration, because those keys probably move a little bit. What do you think?
Oh yeah, I spent a lot of time with speakers that were porting through a grill just to the sides of the keyboards. Even that resulted in a lot of rub and buzz. So I'm hoping that means they've got an awesome keyboard vendor who keeps really tight tolerances, and they don't have nearly as much rattle in their keyboard, or they've come up with some other magic to make it work.
Mm.
Cool. All right, now that we've solved that mystery, back here, another question. I see a couple screws here, Chris. I don't see that they are holding anything down. And any thoughts about what the purpose of these two are?
Yeah,
And
they're just basically screwed right into the housing. It's very, and it's a very thin part of the housing, so there's nothing that it's holding down for anything. Yeah, but maybe again we can look at the other side of the laptop and see, oh, there's some magnets there. Maybe maybe they couldn't find a way to easily embed some, like, magnets or something in that corner, or it's a sensitive area, and so they wanted to just use a sort of magnetic ferrous material on the other side.
Yep.
Yeah, it's a pretty clever way to save some space. They must have been really constrained on either Z height. There would probably be my best guess, and found a pretty clever workaround that's still very functional. What are Molly? I saw on the bottom bucket there was two large pieces of, it almost looks like loose black tape that's covering, there on the left side and the right side. What are we looking at? What are we looking at there?
Sorry, are you talking about here where my cursor is?
To the left of the big shield can in the middle.
Yes.
Yeah, what's going on there, and on the right side as well?
Yep. One thought I have is that sometimes you might be able to see some internals through keyboard openings, and that black tape might be something more of a like cosmetic thing to make sure that you don't end up kind of seeing that variation in coloration beneath your keyboard. What else, Chris? Any thoughts on those?
It looks like it's going over maybe a heat spreader there, so I don't know if it's trying to protect the keyboard, like you said, on the other side, or maybe to distribute the heat that might be coming from that just a little bit more, to get it to a larger surface area. Those look like maybe graphite or carbon kind of heat spreaders.
Yep.
One thing that strikes me here is those screws. I see that one screw that's right above that left battery pack, and that makes me a little bit concerned, just because I remember a couple stories both from my days at Apple and one of our customers here at Instrumental that was having issues with operators that were being a little sloppy putting in screws and accidentally denting the edge of these battery packs. And for any battery experts out there, I know, Molly, you've worked with some batteries in the past. What happens if you start denting? What are the risks if you start poking the edge of these battery packs?
Yeah. So you can be totally fine. I've definitely seen dented battery packs that performed totally normally. But the concern is basically that, if you penetrate deep enough, you start to wear away at the layers, the separator layers between the anode and the cathode. And if those two touch, that's when you have some kind of, event, like something you really want to avoid. So yeah, definitely. I was wondering, if they could have assembled the battery after they assembled the MLB. But I don't know if I see where this battery connector is. So that may be something we want to keep an eye on as we follow this teardown.
Yeah, we'll have to go hunt for that. I've heard too many horror stories about the batteries, but I'm hoping they had a really consistent assembly mechanism here I remember the one customer that we were working with, unfortunately had some of these dented batteries escape, and they didn't know which units, which batches, which date codes. And that's the worst case, because you have thousands, if not millions of units in the field, and you don't know which ones are affected. You're worried about a recall, but luckily they had these images from Instrumental in place. So they went back and actually determined it wasn't that many units. And they were actually able just to do a quick search and found, I think it was like 0.1% of units had these dents, and they were able to quarantine or do a targeted recall for those specific units. So luckily, not a horrendous situation.
Yep. That's
We had some thoughts from Karsten on the an interesting thought on those screws with the magnets, that you could actually adjust the magnet strength based on the Z height. That's a really interesting thought.
Huh. That is really interesting. Yeah.
Yeah, that's possible. I think you could also maybe align your gaps a little bit if you needed something over there. Maybe that's another way to kind of adjust the height. That's interesting.
Yep. Speaking of screws, I also noticed on the trackpad, there are about 6 screws per side to hold this trackpad on, which seems like a lot, but I would be curious for the audience, or for Tobias and Chris, what do we think? Why do we need so many screws there?
That's a lot of screws. Yeah, that was my initial thought of 3. My only guess would be just through reliability testing, and they really want to have a large margin against whatever the lifetime. At Apple, we would do accelerated lifetime testing to, let's say, 5 years. And so they calculated how many cycles of trackpad hinging they need. And they wanted to just add in an extremely robust design here because of the high cycles.
Yep.
Yeah.
Yeah, that actually.
Oh, go ahead, Molly.
I was going to say that reminds me that we similarly, I think, had 12 screws holding the trackpad on, and but I remember even with those 12, we still sometimes had issues in drop, where the trackpad would shift a little bit, and cosmetic gaps then on your trackpad on the front side wouldn't look as nice, but then also there would sometimes be some kind of a performance, trackpad would get stuck or something like that as a result.
Yeah, I mean, I guess the way it's this looks like a traditional trackpad with maybe a hinge on the corner, instead of some of the newer laptops are using like a virtual trackpads, basically with like a linear actuator. So I guess those springs essentially, or dampers in the top side, are just constantly getting stressed every time you push down. So they want to make sure that can last for however long the laptop is supposed to last, 5-10 years. And it's just constantly bending back and forth. So that can make sense why they would need such a robust structure there.
Yep. All right. I wanted to move on to the other side, kind of the bucket side. And one thing I noticed here was this almost looks like Braille. I think we have seen this before, and we've thought that this was probably some kind of machining notation to say which tool was used. We saw this on the Mac Studio, I believe. Let's see, where was it? I think in the housing here at the center. So we see something really similar. It seems like this is kind of a standard now, that a lot of different companies are using. And speaking of these other teardowns, we have recorded all of our previous teardowns, all the 11 that came before this. And so we can put a link in the chat if you want to go back and watch some of these other ones.
Mac Studio one was pretty cool. Yeah, Mark here in the audience thinks tool and supplier, which I think is a pretty good guess of what you would actually want to mark with that. And it's also it's a cosmetically pleasing way of identifying this, and possibly more efficient than writing out the full traceability log. We also had a question on the air intake. Looks like there's only one fan. Did the bucket have some cutouts for the air intake? Seems like it's pretty closed off from what we've seen.
Yeah.
Thermals, that's a great question. What do you guys think?
Yeah, let's jump another couple pictures here. And we took off that shield can, and we also took off the speakers here. We can take a better look at what's going on thermally. So we probably have the processor behind here, and then we have these large heat pipes. And this fan we were able to see, but the intake is still a good question.
Yeah, I mean, I can shed some light on that. I've taken out a couple of things. So there is a let's see if I can share my screen. Yeah. So I think on the back side of the laptop, you see this large set of ports or openings that I think seem to be machined out. And then on the inside, you see, if you can ignore the ring light there, but there's a bunch of these large openings down here. And I think that's where the fan, comes or exhausts from. And so, yeah, so I think they've machined in a bunch of these ports in there, or these openings, to get access. And then that thermal heat pipe solution just kind of distributes all the heat through it. So that must be, I think that's how the air flows through the laptop.
And I remember we had a really interesting discussion on thermals in one of the previous teardowns. I think it was the Mac Studio, when there was so much volume dedicated to just thermal management. And I learned some really interesting things about how that heat pipe is actually designed. Does anyone in the audience, a thermal design expert that wants to explain what's actually going on with that heat pipe to make it dissipate the heat so effectively? Do you guys remember, Chris and Molly?
I feel like there's these are very special. They're not, when I first saw them, I thought they were just copper tubes or copper pipes or copper pieces, but I think they're actually tubes filled with some kind of liquid that when it heats up, maybe it turns into a gas, and that the state change kind of allows for some cooling, and then it also moves the gaseous part towards the ends of the pipes, and then when it cools, it comes back down into a liquid form, and then it moves back the other way. So it's sort of a self-contained heat pipe.
Yeah, I remember being very impressed when I learned that it was actually this complex system of heat transfer. When I had previously assumed that it was just conducting through a solid piece of metal there. So it looks like that's what's going on here as well in the thermal management.
Yeah, and you can see they've sort of bonded this other copper plate onto here. This is just a single piece, so they're really trying to spread this heat quite a lot.
Yeah, it's an impressive thermal design for such a compact laptop here.
Yeah.
Yep.
Should we? I know you took off the trackpad as well on the other side. Do we want to take a look at that before we continue on with the bucket?
Sure. So I was able to there was a big shield can that covered everything, so you can kind of see underneath here. So you can see there are those 6 screws that Molly was showing us earlier. I think there's another little shield here, but I think that's a little hard to see too much more than what I'm showing here. Maybe we can switch back to Molly.
Yep, happy to do that. All right, so we are looking at that trackpad. And one thing I noticed was these 3 different flexes that are coming down underneath the shield can. And we actually have a little bit of a quick video, kind of our new ability to also put videos into instrumental. And the idea would be to be able to see, how repetitive, how consistent your SOPs are being followed on a serial number by serial number basis. So let's take a quick look at this video, and maybe people can just throw into the chat what they see going wrong here on this terrible operator who is trying to plug in. I think that may be the keyboard flex coming down.
Are those your hands, Molly?
Those may be my hands. Yeah.
This is an operator, right? This is an operator.
Mm-hmm.
Oh, what was that?
Are those metal tweezers? Ooh. Yeah.
I want to hear. This almost reminds me of our teardown bingo from last time in person. Can you identify 3 concerning items about that video? What did you see, Chris?
Yeah, I think there was definitely the metal tweezers near like a sensitive FPC, a sharp possible tearing possibility there. Yeah, I don't know, Molly, what else did you see? I mean, as an operator, maybe you thought you're doing the right thing, but in
yeah,
the cold light of day on this Insta, maybe you can see it.
Right. I think I also had the finger cuts on maybe 3 of my fingers, but also ended up touching the unit with one of my fingers that did not have them. Anything else you saw, Tobias?
I was concerned mostly with the metal tweezers, as well as it looked like you may have missed the actual ZIF connector with a few of the pokes there. I'd be curious what instrumentals technology might be able to find after the fact. Some of the collateral damage of the flex insertion or what else. Could you show us a little bit about what could happen there?
Definitely. Let me hop over to another little demo project that we have here. And we can look at another ZIF connector in this camera product. And so what you can do with instrumental, you can see all of your different serial numbers here, every single serial number you've built. And anything that you're particularly interested in, you could select a region. You can draw your box around this connector specifically, and you can look for the most anomalous. You can also look for the most similar if you're looking at something that is already wrong and you want to see, kind of like your story before, Tobias, which serial numbers were affected by this given problem. So let's see what our AI comes up with. Looking through all these parts. All right, we have a couple where the latch did not get latched. We've got some corrosion here. We also can see, this latch is broken, and we see a bunch where the latch, it seems kind of crooked, I would say. It seems like this didn't really go in at the right angle. And so when I see that, I can even click on this and say, okay, this is the specific problem I want to understand, kind of the extent of. And so now I can see all of my more crooked insertion flexes specifically. And I can see here the serial numbers, the exact date and time when this happened. And then I can even set up a live intercept that will push back to the factory so that in the future we don't continue seeing that.
That one's a really tricky failure mode too, with the crooked flex. I've had some horror stories on that, because that's probably still going to pass the final functional test. So it's going to pass at time 0, and then it's a high risk for a failure in the field.
Yep, definitely.
One thing here for anyone in the audience as well, again, we'd love to hear from anyone that's worked on laptops about what you want to see as we continue on the teardown here. The demo here that Molly's showing, we don't actually have laptop publicly available images that we can show, but we can actually take in images and do custom demos if you have images of laptops. So if you're interested at all, please reach out to us, communications@instrumental, and send over some images, and we can just upload them here. It's super quick. And then Molly can show a similar workflow of how it can find all these different anomalies within the laptop images.
Great. I know a topic that some folks have been interested in around the laptops is keyboard mechanism. Maybe we could take a look at that next. I did take a couple apart so we could zoom in here on both a 1x1 key and then the space bar, which I thought would be kind of interesting. So what we're seeing here is pretty normal scissor mechanism, none of those butterfly mechanisms. And also things I thought were interesting, we're sort of looking at these torsion bars. Those are going to help make sure that, even if you hit the very edge or corner of the space bar, you still have a good feel that is, as consistent as possible with being just above the dome switch here. Yeah, I know some of the laptops I worked on had, maybe even like 3 dome switches in the space bar to make sure that no matter where you hit, you're always registering that click. But I'm assuming with there's stiffness coming from the torsion bar, and there were also some torsion bars, like a smaller set that lived inside the key here. I assume that means that they've kind of solved the problem in a different way.
What are some of the trade-offs with the 3 keys? Do you have to do you sometimes depress 2 of them, or is there a debounce kind of thing? What happens when you do that?
Yeah, I think there were some more difficult pieces to the electrical engineering of that. I wasn't too deeply involved, but I do remember that was, you had to kind of think about all those corner cases.
Mm-hmm.
I know that a lot of people have strong opinions about the types of keyboard as well as the travel, both from the actual design side, if anyone's worked on it, but also just from using it. There's been such a large variety. I know Apple has done a lot of design changes in one direction or the other on their keyboards. I'm always curious to hear if anyone in the audience has strong opinions on the types of keyboards. I want to hear them.
Yeah, I can speak a little to that. There was a trend in the industry to kind of go smaller and smaller stroke or travel, and getting down to, I think, on the order of 0.5, 0.6 millimeters, and especially with those butterfly key mechanisms, that was kind of the goal, is to be able to make a really thin base by reducing the amount of keyboard travel that you needed. There's almost been a pushback from that there's been a realization in the industry that actually people kind of prefer something on the order from 0.8 to maybe even 1.1 millimeters of travel. And so I think people have started kind of in a rare thing, getting a bit larger. Are always kind of making everything smaller and smaller. And this is one place where I think things have actually gotten a little bit bigger in recent years, but to customers' delight, I would say.
All right, great. So there's a lot more that we want to dive into as well. Any particular feature on the laptop here that you guys want to make sure that we spend some time on? Chris, how are we looking on the rest of the bucket?
I think I'm able to get something out here. Give me a second. So let me share my screen. You can see my struggle here. I've gotten a lot of this stuff out. Now I'm just kind of wondering why this is there we go.
Hey, there we go.
There's so this is the main PCB. I had to take off 2 other shields besides that main one because there were 1, 2, 3, 4 screws that were hidden underneath. So this is a little bit tricky to get into. I think one other thing that was interesting is that the battery connector is actually on the underside of the board. So, when you open this up, it's interesting to see that, oftentimes the battery is one of the first things that gets taken off. But because of the way that this is constructed and they kind of screwed down the board around this connector, there must be some other mechanism so that they're not constantly powering this as you're mucking around inside and taking things off. So I think that was a really interesting thing. There's some other kind of curious things that maybe Molly would like to take a look at later on so we can zoom in, but like this looks like this RF module is kind of askew, and there's like a little cable here for some reason. A couple of other fun things, like this audio jack seems to be modular. I can just take it out, and it's also got a lot of spring fingers on it. So again, some of these things that Molly was pointing out earlier, like the keyboard being easy to replace, some of these things are the big failure modes, so maybe they can get in there. But yeah, anything else that anyone wants to see? Otherwise, we can kind of flip this over, or just send some things in the chat. One other interesting thing is there's these kind of ribs right here. They're just kind of slightly raised. And I'm kind of curious, Molly or Tobias, what your thoughts are on why there's these little ribs in the middle of this main board.
That's a great question. I've got some thoughts, maybe tying back to my first thought was actually around airflow from thinking about it before, but I think there might actually be a different reason. What do you think, Molly?
Yeah, I was thinking that is sort of, those are your points where that big heat pipe is really like springing onto. And so I'm sure you don't want any flex in your board. And those ribs might just provide the structure to avoid that. Yep.
Yeah,
that's a good thought.
Yeah, I guess that chip probably doesn't want to bend. Looks like I don't know if this is the Intel one, or I think yeah, it's probably an Intel chip. But yeah, is there anything, let me see, maybe we can dive in and take a couple.
Actually, Chris, one last thing before you hop over. I thought there was some interesting angular housing cuts.
Oh, yes, that's right. So one of the interesting things, I kind of showed these a little bit earlier, but there's these, where's my finger? There's these cuts on the sides here. But what's actually funny is it's actually an undercut. So it's almost impossible to use, okay, focus. It's almost impossible to use, some kind of tool to get under there to cut it. So kind of curious what people's thoughts are on how they're able, sorry. Hello, let me refocus on instrumental. There, no, focus.
It really doesn't want to focus. It wants to.
There we go.
Into it.
But yeah, how do they get those holes basically on an undercut surface? I'm trying to see if I can get this into a different angle. But what are you guys' thoughts? Like, how do you think they got in there to get those holes?
That looks really, really tough to machine. They must have done some really intricate DFM cycles. I'm just thinking about how many times they would have had to go back and forth with the vendor to try to get that angle right. It almost, could they come in from the backside once you take off the display? Could they come in from the backside to drill the hole?
I think that's probably the best theory here, just because there's this like chamfer in the back, and so maybe they can kind of come in from that side. And as you're mentioning that, Tobias, it does look like the holes, they're not perfectly circular, they're kind of squircle-ish. And so maybe there's a way that they kind of came in at an angle and just made like a squarish pattern to get the maximum amount of hole space, airflow space, but to still maintain that structure, because it's a pretty thin aluminum beam there, or body. So yeah, I think that's a really interesting thing. I'll try to take off this display. Maybe Molly, we can go back and look through some of the stuff on instrumental while I do that.
Sounds good.
It looked like Aaron had a theory on a beveled end mill to make those holes happen. Okay. I think either way, it's looking overall at the design, it's impressive attention to detail, and you can tell that they're really investing in more of the high-end feel and finish. I know we were talking about the cosmetic gaps around there looking really nice, especially with the magnet closure. So I was really impressed with a lot of those design decisions.
Mm-hmm. Definitely. Yep, I agree. Another thing I thought was I think this is a clever design decision if I'm thinking about this correctly. So I'm looking at the hinge, and I see this almost like U shape built into it. And I have a theory, but I want to hear other people's theories on why that might be there. The screws, there's kind of 1, 2, 3 screws up here, holding that flange on.
U-shape connector. So the U-shape is on the left part of the hinge.
Yeah.
Is that right?
Yep. So that's the like base side flange. And then there would be a lid side flange that probably has a few screws kind of into the lid enclosure.
Well, that's a tricky one. Any thoughts from the audience? It's clearly an intentional design feature. My only thought would be some type of assembly aid, because it doesn't look to be serving a final purpose there. Looks like Mark has an idea. It's a part of the 1 finger to open spring.
1 finger to open spring. I don't know if I totally understand that.
That means so when you lift it up from the finger, like the Apple laptops, so the to open the top.
Yeah, like the ability to do one-handed opening. That was definitely something we spent a lot of time on, was hinge calcs, understanding in these different scenarios, if there's some amount of vibration, is your hinge going to kind of slip? So you wanted to have an amount of holding force and think about how heavy your base is, how heavy your lid is, and kind of play that perfect balance while also battling tolerances that are associated with the actual torque of the spring, or torque of the hinge.
What do you think it is, Molly? Okay.
I think I'm with you. So when you're holding a bare hinge, it can be really hard to rotate it, and especially here where they have this like 3 screws that are all kind of in one line, you don't get a very big lever arm if you're just trying to let's say rotate it so you can assemble it into this base, and you need to be at the right angle in order to be able to do that. So I think it is kind of an assembly aid so that your operator can open it up to the proper angle and then assemble here.
Yeah, that makes a lot of sense. Just anecdotally, it's really hard to move those things, but I am able to move them without like breaking the display. So that is a positive.
Yep.
It's not easy, but probably easier than if they didn't have that little extra lever arm there.
Yep.
I saw that antenna cable hanging there, which remind me of Chris's little mystery on the main PCB. If we take a look at that antenna, looks like a little coax cable with a rotated. What do you think is going on there?
Yeah, I mean, 2 interesting things. One is the sort of 20 degrees of rotation of the probably like Wi-Fi card itself. And then the other thing that's interesting here is this coax connector, and it seems to go basically from here onto the board. So yeah, I'm actually not totally sure. Chris, you have any ideas on that one?
This is very interesting, because if that module looks like it's soldered down, and they might have been able to put like a 50 ohm line directly underneath it, but maybe they didn't. The connection for those solder points maybe is too critical, so they needed to have an actual guaranteed coax connector to do that. But it's such a small little antenna. I don't know, maybe there's a reason that it has to be at this particular angle for some kind of antenna performance metric. But yeah, I don't know. That's a very interesting use case for this.
It's very bizarre to me. My initial take is they must have had a compelling design reason to implement this as a coax cable rather than routing it through the board, because I know both from personal experience at Apple, as well as one of our customers here, those coax cables can be a huge pain. This actually reminds me, not only just plugging them in is a huge pain, but let me actually pull up here. This actually reminds me of one of these really needle in the haystack failure modes that one of our customers had, where the coax cable, they were getting this series of antenna failures. I think it was like 4 or 5% during one of their engineering builds, and they had no idea why. So they go into all these different hypotheses about what could be causing antenna failures. A lot of people know antennas are very hard to diagnose. I always thought it was kind of a black box of all the things that affect it. And using instrumental, they actually correlated the poor antenna performance to a very slight angular shift in these coax cables. Something that if you look at one part when you're doing FA, there's no way that you would have come to the conclusion that that 20-degree shift in a coax cable is causing all your antenna issues. But when aggregated across the entire population, instrumental found that all the ones that were rotated actually had this worse performance. So such a needle in a haystack sort of failure mode that luckily they're able to diagnose and then put checks in place to actually monitor it going forward. But because they're so finicky, that's why I'm thinking they must have a really good reason to actually implement that coax cable outside. If anyone else has ideas on why they think it was rotated and had a coax cable, would love to hear here. And I know, so maybe Molly, if you want to dive back in, we've got just a few minutes left. So if there's anything else that you guys want to make sure we cover that we haven't talked about yet, let us know.
Yeah, one thing I wanted to talk about a bit was, so we've got 4 flexes coming from lid to base. I'm assuming we've got display, we've got touch. I know we've got a camera up there. What do people think that 4th flex might be?
Four connectors. I know the camera module up there has a huge variety of different sensors. It almost looked like a Face ID type infrared sensor. Do we think all of those are in one of those connectors, Molly? What do you think?
Yeah, I would have thought so, but it is possible that they're maybe split up. Like I would think you probably have like a board at the top of the display, and you have one flex that goes there. But there may be a reason they needed to get split up.
I don't know if this is a LCD display or an OLED display, but maybe like Ron is saying, maybe this is a backlight.
I think it is LCD. Yeah.
Okay. Yeah. So it could be maybe a backlight, and it's bigger than what I used to. At Amazon, we had front lights because the display was a like e-ink panel, but we would have like 8 LEDs or 10 LEDs, and I guess for a screen this big, you probably need more than that. And so, and to do like local dimming or something like that, maybe you need more pins to control the matrix of LEDs.
Yep. Yeah, one thing I forgot to mention before, but I really do think laptop, based on my experience, is a great use case for instrumental, because you can think about a picture like this in a single image. You're getting like probably 70% of what you want to see. Maybe you get one other picture for every unit of like the lid internals. And if you want, you could do, a keyboard or trackpad picture, have some kind of like bonus images where you haven't getting coverage. But I think it is really great that, you could have coverage as simple as 1 or 2 images and just have these really information rich. You can see, all the things that I think about that I would debug when I was working on laptops, or like speakers, batteries, things on the main board, like IOs, antenna. You can see all of that in one picture. So that's pretty awesome.
You think there would have been a use case when you were working on Chromebooks for something where you might have found something a little sooner?
Oh yeah, definitely. I mean, I mentioned before that I worked on a lot of rub and buzz problems. And there were just so many theories that even the ones that, you end up disproving, you spend a lot of time trying to disprove those theories by getting physical units, by pulling test data into jump one by one, plotting things and kind of guessing at making assumptions and then finding out if they were right or not. I think it could have been a huge time saver. I mean, that's why I'm here, to be honest.
That makes a lot of sense.
Do you want to show actually, because again, the correlations feature, that's like the PD engineer's dream. That was kind of just the use case that I talked about. Do you want to show just a little teaser of, like, let's say you had that rub and buzz data in a system like this, and instead of spending weeks doing failure analysis, what that FA loop would look like here?
Yes, definitely. I think we don't have a speaker here in the Rilo camera product. We have a lot of different images throughout key assembly states. And then we also have functional test data, and we don't have speaker data, but we do have mic data. So I think we could hop into that and, imagine the scenario instead. I was trying to debug mic issues. So really quickly, I can look at specific units and see how they did on those functional tests. And I can also see the whole population here in a histogram. And if I'm interested in something specifically, I can click into that and go into our correlations tool. With literally one click, I can correlate all of the different test metrics and even measurement values that I have here. And so I'm able to find where I have correlations. And so we're highlighting things that are very likely correlated at the top. And that's a correlation with this overall front mic functional test. So some of these are, kind of those children tests that make sense. But you might be able to find things that you didn't expect that turned out are correlated. And that might help you, make some steps along your way to finding that root cause. You might be able to correlate things like, when the mic comes from vendor A, it's more often failing, and vendor B is never failing. And then you can go dig into things like, is there a difference in quality, or is there a difference in design between those two vendors? And you can also, besides just looking at the correlations in the test data, you can also look at the correlations with all the visual defects that our AI has automatically picked up in your image. So after 30 images, our AI kind of understands what normal is, and then it can start highlighting things that it thinks are abnormal. And here it pairs that with the functional test data to say, I've looked through all your images, and these areas highlighted in red kind of have more correlation with being likely to fail. And so in this case, we're seeing this is my mic port. I can see on the outside of my enclosure. And I seem to have some kind of debris in there, or this almost looks like some kind of like a molding defect. So maybe I have a couple of different root causes here, but I know as the engineer coming into this that these are all things that would definitely affect my mic performance results. I can set up that monitor and I can start, watching for those things live. So, in the future, I don't have to worry about this. And I can also communicate with my team here. And I can go ahead and, highlight that I know this thing was on our MIL, and I've already figured out what the root cause is here. If that's not my reason, I can keep scrolling down and I can look for other things that the AI thinks might be related. There's no need to program anything. It's not like the AI doesn't necessarily know that this hole is related to mic performance, but it does know that there's a correlation. When this region looks different, it's more likely to be failing that mic functional test.
That is so cool. I had similar issues on a different kind of product, and it was like tearing our hair out trying to figure out what was wrong. And then you're just testing bogus theories, just whatever anyone could think of, and you're like, yeah, I guess I got to run a DOE on that and like run a bunch of different parts. And we never got the chance to look back up what actually went wrong, because you might be destroying the parts as you're opening them, like figuring out what went wrong, especially around antenna issues, because you could dislodge something really quickly. Or we had something on a pressure sensitive sensor, and it was just not working all the time. And we're like, what is happening here? And as soon as we open it up, it just tore apart everything that we had that we were looking for. So I could have definitely used this, and it would save a lot of time.
Excellent. Well, yeah, thank you, Molly. Again, this is like the PD engineers, as well as a lot of the quality teams that we work with. I wish we had this. Could have saved a lot of long nights at our China factory. So we've got just a few minutes here. We didn't even get to dive into the whole display and check out all the optical sensors up there. Anything, Chris, that you want to highlight before we wrap up here?
I at this point, I think if anyone has anything that they want to see, it's a really pretty clean system, actually. It's a beautifully machined parts, and you've got the bucket construction, which as you can see here, I was able to take about almost everything in it. But yeah, not too much else that I can think of at the moment. I love the magnets that are kind of holding the front around. I thought it was a really clever solution. And yeah, at this point, I don't know if I have anything else. What about you, Molly?
I don't think so. Yeah, I'm impressed with this. I think it's a really, really well-designed laptop. So yeah, excited to even see what's next for Microsoft and their laptops.
Absolutely.
Excellent. Well, I think that's a wrap then. Thank you everyone for joining and participating in this. We'll save that screen for maybe a future teardown. A few reminders here. We actually have this great summary. We did a survey of a bunch of manufacturing companies in mass production about some of their biggest challenges. And we're actually going to post the link to that digest of data. Check that out. If you want a customized demo, or if you have images that you want to evaluate in our system, please reach out, communications@Instrumental. We can set that up. Survey, let us know what you want us to tear down next month. Even more exciting, we have a teardown coming up in September of the Sonos Roam, and we're going to be featuring Ron Roberts from Sonos, who's a design engineer there. So super excited to get his perspective and collaborate on that teardown. So that'll be posted in the comments here. So please go ahead and sign up, and we look forward to seeing you next time. Thank you to Team Teardown. We'll see you guys next month.
Thanks, everyone.
Thanks. Take care.
Manufacturing is changing, and keeping programs agile and on schedule is harder than ever. Leading engineering teams rely on Instrumental to find issues earlier, fix them faster, and make sure they don't come back. Experience the first manufacturing optimization platform designed to enable continuous improvement of your process, from development through production, by unifying your data so your teams can make decisions faster. Instrumental makes finding correlations in product data easy, so your engineers can spend less time wrangling data across email, spreadsheets, and internal systems, and more time solving problems. It's simple. We put the right data in front of the right people in real time. Instrumental aggregates images of every unit at key assembly stages, parametric test data, and measurements in real time in a secure, managed cloud. When installed across factories in a supply chain, brands and suppliers are able to work together to solve their most complex issues. From your first build, Instrumental's Discover AI proactively identifies new issues by scanning your products for anomalies and automatically delivering a daily queue of issues. Engineers can jumpstart failure analysis with defects in context. Engineers leverage a rich, remote dataset to quickly identify correlations and potential root causes, and can push live tests to validate solutions immediately. They use Instrumental to eliminate issues at the source and make sure they don't come back. With complete build and issue analytics for the entire team, program leads can kickstart daily stand-ups, streamline executive reporting, and communicate seamlessly with global teams. Instrumental has helped leading engineering and operations teams move faster, improve yield, and build better products from proto through production. Better products start with better data. Better products start with Instrumental. Schedule a demo today